Hi there, welcome to my channel mathssl. I'm speaking Thaqib Latif. This is the question DBE May June 2023. The question says f of x is equal to x power 3 plus 4x power 2 minus 7x minus 10. So the first question say write down the y-intercept of f. So the y-intercept is this one, negative 10, 0 and negative 10. This is the y-intercept. Second question, show that 2 is a root of the equation f of x is equal to 0. To show that 2 is a root, we must show that f of 2 is equal to 0. So the f of 2 must be equal to 0. Substitute x is equal to 2 into the original cubic equation and answer must be equal to 0. So I substitute x is equal to 2 into cubic equation and answer is equal to 0. Question number 8.3. Hence factorize f of x completely. We need to factorize this one completely. Since we know x is equal to 2 is a root, therefore x negative 2, always we say x is a liar, we do opposite. X negative 2 is a factor of f of x, is a factor according to the factor theorem. Now this is a short bracket. To find the long bracket, I'm gonna use the synthetic division. You can use the long division also, or you can use the by inspection, or you can use the calculator as well, but I'm going to use the synthetic division. So I need to list all of the coefficient of the cubic equation. So the first is 1 and positive 4, and then I have negative 7, and I've got the last constant is negative 10. Now I'm going to divide by 2 because 2 is the root. We will use synthetic division with the root 2 and the coefficient of f of x. So now bring down the first coefficient 1. 2 multiply 1 is 2, and then add 6. 6 times 2 is 12. I'm gonna add again, so answer gonna be a positive 5. 5 times 2 is positive 10. I add, answer is 0. If you see the last answer is 0, then which means x negative 2 is a factor. Now the long, and this is ax squared plus bx plus c. So the x negative 2, I've got a short bracket, and the long bracket gonna be now x squared plus 6x plus 5. So I need to factorize x negative 2 short bracket, and this one long bracket I'm gonna factorize. If you can't factorize, use the quadratic formula, but I can factorize here. So it's gonna be a x plus 5 and x plus 1. They are factorized. So these are the factors of f of x. So therefore these are the factors of f of x. Must remember in 8.3 we need to just factorize. We don't need to solve for x. 8.4. If it is further given that the coordinates of the turning points are approximately at 0, 7, that's the x value, the y value negative 12, 6, and negative 3, 4, and 20, 8. Draw a sketch graph of f and label all intercepts and turning points. So we need to sketch the graph now. To sketch the graph, we need y-intercept, we need turning point, he already give us. X-intercept we need to find. But remember, to find the x-intercept, we from the factorization in 8.3, the roots are x is equal to 2, and x is equal to negative 1, and we have x is equal to negative 5. These are the x-intercepts. So the x-intercepts are negative 5 and 0, negative 1 and 0, positive 2 and 0. These are the x-intercepts. So now we can sketch the graph. We have the x-intercept, we have the y-intercept, we got the turning points. So randomly you can sketch the graph and then you can plot the points. I randomly sketch the graph and then I plot the points. So there we go, this is my f. So these are my three x-intercepts: negative 5, negative 1 and positive 2, and this is a y-intercept negative 10, and this is the turning point 0, 7, and the y value negative 12,6, and 0, 7, negative 12,6, and then this the top one negative 3,4, and y-intercept is 20,8. So you don't need to be according to the scale, just randomly you need to sketch the graph. So this is my graph. 8.5, very interesting question. The first is use your graph to determine the value of x for which first derivative less than 0, which means negative first derivative. So the graph is increasing by the turning point decreasing, and by the second turning point again increasing. So where is the graph increase, first derivative is positive. Where is the graph decreasing, first derivative is negative. So between these two turning points the graph is decreasing. So between negative 3,4 and 0,7, this is my answer. My answer gonna be a negative 3,4 till 0,7. The graph is decreasing, and the first where the graph is decreasing, first derivative is negative. So this is my final answer. So the next question is 8,5,2. So need to give the value of x for which the gradient of a tangent to f will be a minimum. Now before I solve this question 8.5.2, the gradient of a tangent to f will be a minimum, I need to explain to you this concept. Must remember, this is a positive cubic graph, this is a negative cubic graph. Now the derivative of the cubic graph is a parabola, that you know. Now gradient of the tangent is equal to the gradient of the graph at the point of tangency. Now the derivative of the cubic graph is a parabola. Now so the gradient of the graph is a first derivative. So the first derivative of cubic graph is a parabola, this one. Now minimum, if you look nicely, the minimum value here is a minimum value by the turning point. So the parabola have minimum value, and here at this point this is the negative parabola as maximum value at this point by the turning point. Now so therefore the stationary point, turning point of the parabola is the point of inflection of the cubic graph. So if it is positive cubic graph, by the point of inflection here is going to be a minimum gradient of tangent. So the tangent is the line where the graph only touch once. So must remember, let me draw the tangent line. Say this is the tangent line. So by the here point of inflection is going to be a minimum gradient of tangent. And if is must remember this is n, so this is a positive cubic graph, happy cubic graph, and this is the negative cubic graph, and always gonna be a maximum gradient of tangent, and here gonna be a minimum gradient of tangent. So must remember. So therefore positive cubic graph at point of inflection here, minimum gradient of tangent, and the negative cubic graph by this point of inflection, maximum gradient of tangent. So must remember this one. The first derivative is a parabola. This is the first derivative graph, this one, and which is a parabola. The minimum value by the turning point of the parabola is the point of inflection of the cubic graph. That's why, so the minimum gradient of tangent gonna be by the point of inflection, because you can see this graph is, this parabola is concave up. So the concave up, minimum value, concave down, maximum value. That's why in negative cubic graph, at the point of inflection will be a maximum gradient of tangent. Now we come back to our question. He say the gradient of a tangent to f will be a minimum. So minimum mean, so positive cubic graph, and that will be here, so by the point of inflection, because the first derivative, the parabola, minimum value will be at the point of turning point, because the first derivative is the parabola graph, because the first derivative is parabola, at the turning point of parabola minimum value, and turning point of the parabola is point of inflection by the cubic graph. That's where the minimum gradient of tangent will be here by at the point of inflection. Now we come back to our question. Must remember now here, so that we need to find the point of inflection to give the answer for this question. To find out the minimum gradient of tangent, so will be by the point of inflection. So now because this is a positive cubic graph, so therefore minimum gradient of tangent will be on positive cubic graph, and maximum gradient of tangent will be on negative cubic graph. So now we're looking at minimum gradient of tangent, so that will be on positive cubic graph, and this is a positive cubic graph, and that will be on point of inflection. So we need to find the point of inflection, and that will be our answer. So the point of inflection I'm going to find here, I'm going to use the midpoint of these two turning point. So the negative 3,4 plus 0,7 divided by 2. If I take the midpoint of these two turning point, that will be my point of inflection. So that answer will be negative 1,35. That is my answer. So that will be here somewhere. This is negative 3,4. This is 0,7. So the negative 1, this is negative 1 here, negative 1,35. That will be here somewhere here. So this is negative 1,35. This is my point of inflection. So at this point, minimum gradient of tangent. So therefore minimum gradient of tangent will be at point of inflection. So this is my final answer. Now the last question, use the graph to determine the values of x for which first derivative multiplies second derivative less than 0, which means negative. So I'll show you how to solve this question. Now the question says first derivative multiplies second derivative less than 0, which means negative. So we need to make a table here. First derivative of x and the second derivative of x must be negative. So the first derivative must be positive, second derivative must be negative, positive times negative, answer going to be negative. Or first derivative must be negative, second derivative must be positive. Negative times positive, answer will be negative. So let's see these two scenarios. So first we need to find out where is the first derivative positive and negative. So math start left to right. So f is increasing here. Where f is increasing, the first derivative is positive. So which means the first derivative positive here. And from the turning point, the graph is decreasing. So the first derivative is negative here. Again from this turning point increasing. So the first derivative is positive here. Remember, point of inflection is here, negative 1, 35. So the graph is concave down till the point of inflection. From the point of inflection, the graph is concave up. Where is graph concave down? Second derivative is negative. Where is graph concave up? Second derivative is positive. Now I can give the answer easily. Now, math start left to right. So we're gonna start left hand side. And here the first derivative is increasing, which means positive, and the second derivative is negative. So which means this condition will meet here. So I'm gonna highlight here, first derivative is positive, second derivative is negative. Positive times negative, answer is negative till this point. So the x value is negative 3, 4. So the first answer, first interval, so the first interval will be x less than negative 3, 4. And this inequality is included because he's say less than or equal to 0. So the negative 3, 4 is included. Oh, now second interval. So now we're going to look at the second scenario. Positive, first derivative positive, second derivative negative. Now, if you look here, from this turning point here, the first derivative is negative and the second derivative also negative. So I can't choose this area because negative times negative gonna be positive. But from here, point of inflection, first derivative is negative and the second derivative is positive till this point. Negative times positive, answer will be negative. So I'm gonna use this interval between negative 1, 35, and obviously this is included till the 0, 7. The graph, the first derivative is negative, second derivative is positive. Negative times positive, answer is negative. So this is my second interval. But from here you can see the first derivative is positive and the second derivative as well positive. So we cannot use that because positive times positive gonna be positive. So these two interval, this is my final answer. The inequality holds for these two interval. So the inequality holds for x less than or equal to negative 3, 4, or between negative 1, 35 and 0, 7. Please like and subscribe my channel. If you have any question, comment below. I will assist you. Have a nice day.